All right, everyone, how's everybody doing? So I'm going to go over the POGIL isotope worksheet with you guys. And I'm going to share my screen here and let's see. Okay, so here we go. So this is the POGIL that you should have had, and I'm going to go over what the different things are here. So in this first thing, it's you're going to identify here, and the first thing I want you to fill in the model 1. This is model 1, okay? And see, it kind of gives you a snapshot of what's inside the nucleus here. And so the little dot, dark dot with a positive is going to be your proton, and then the circle with nothing in it is going to be your neutron. So in the first one, we have 1 proton, 0 neutrons. And then we have 1 proton, 1 neutron. And then over here, we have 1 proton and 2 neutrons. So you're just counting the little individual particles here, right there, the circles that are magnified. So that's the nucleus that's magnified. Go down to the next one, okay? And number of protons here, and you count them. And for carbon, you're going to have 6. And then you count the circles for the neutrons, and you're also going to have 6. Move to the next one, you have 6, and then you have 7. 6, and then you have 7, okay? And you're counting all those little individual circles there, okay? And you go to the bottom one, magnesium, you have 12 here, 12 here, 12 here, 13 here, 12 here, and 13 here. And you notice on all of these that the protons are never changing. The neutrons are the only ones that are changing in these samples, okay? We're going to get into more of that in a minute. Okay, so now let me flip my page over, and it says refer to model 1. Okay, refer to model 1. Which subatomic particles do the following symbols represent in the atomic diagrams? So the dash here, that represents electrons. The positive is protons, and this neutral circle are neutrons. Okay. Then it says, find the 3 electron elements shown in model 1 on your periodic table. What whole number shown in model 1 for each element is also found in the periodic table for that element? Okay, so what whole number? So that's what you have to look for hydrogen, it's 1, carbon, it's 6, and magnesium, it's 12. Now, so they're wanting you to look at the periodic table, and they're wanting you to say, okay, which one also in the periodic table is a whole number? And those would be your whole numbers, okay? The whole number in each box of the periodic table is the atomic number of the element. What does the atomic number of the element represent? So if you went and flipped back to model 1, you would see that the atomic number represents the number of protons. Okay? Then it says refer to the isotope symbols in model 1. Relative to the atomic symbol H, C, or Mg, where is the atomic number located in the isotope symbol? So remember, the isotope symbol is up here, okay? So where is that atomic number located for each of the isotopes? It is located in the bottom left, okay? Bottom left. Now, refer to your periodic table. How many proteins are in all atoms of chlorine? So chlorine has 17 protons. A student says, I think that some chlorine atoms have 16 protons. Explain why this student is not correct. Okay, because if I said 16, okay, if I said we had 16 protons, and that's the atomic, equals the atomic number, okay, I go to my periodic table, I find the element that has 16, the number 16 for the atomic number, and I'm going to see that atomic number 16 is sulfur, not chlorine. So that's why they are incorrect, because if you can't change the number of protons, excuse me, because if you do, then you're actually changing the element itself, okay? So you can't do that. All right, refer again to model 1 in the isotope symbol of each atom. There is a superscripted raised number. This number is also used in the name of the atom. It is called the mass number. How is the mass number determined? Okay, so if you look at model 1, you will see that the mass number, okay, if I can flip this page over, the mass number here and here and here is the total number of protons and neutrons. Okay, if you add them together, that's where you're going to get the mass number. So how is the mass number determined? It's protons plus neutrons. Okay, why is this number called a mass number? The reason it's called a mass is because protons and neutrons together make up the entire weight of the sample, or of the atom, let's say. So it's called the mass number because the whole mass is concentrated in the nucleus, and that's what makes up the whole mass of the atom. So those two together, so that's why we call it the mass number. Okay? All right, now flip your page over to the next diagram here. It says fill in the table for atom 1 and atom 2 shown below. Okay, so you would count all of your positive protons in this and say 1, 2, 3, 4, 5. Okay, so you have 5 there. 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 there for protons. Neutrons, you have 1, 2, 3, 4, 5, 6. Okay, mass number is going to be 11 because you add them together. And then here you have 1, 2, 3, 4, 5, 6, 7. And mass number is going to be 16 there. Okay, which corner of the isotope symbol contains the mass number? Okay, well, if we refer to our model over here, okay, the mass number is at the top left. Okay, how is the mass number of an isotope expressed in the name of the atom? So if you're doing the isotope name, you would say isotope name, a dash, and then you write the mass number. Okay, write an isotope symbol similar to those in Model 1 for each of the atoms in question 6. Okay, so you could go look up the atom for this, or you could even call it atom X. Okay. Okay, so you would say X has, or let's just go ahead and identify it. If I know that it has 5 protons, that means I know what element it is if I look it up on the periodic table. So it's going to be boron, and it's going to have a mass number of 11 and an atomic number of 5. Okay? And then the other one is going to be number of protons is 9, which is going to be fluorine. So I'm going to put 16 here and 9 there. Okay? And now it wants to know, write the name of the atom. So we'll say boron dash 11, and this one would be fluorine dash 16. Okay? All right. Now here, atomic number, remember, is at the bottom left. So I'm going to write 19 here. Mass number's at the top, so that would be 40. Number of protons is the same as the atomic number. So we're going to say 19. And neutrons, to find neutrons, you would subtract these two, right? So 40 minus 19, okay, is going to be 21. Okay? Now for the next one, for fluorine, atomic number is 9. Mass number is 18. Number of protons is 9. Neutrons, you would subtract 18 minus 9, and it gives you 9. And then the last one, we have atomic number 16, neutrons 15, so protons are going to be 16. Mass numbers, where you add them together, that'd be 31. Okay, what element has an atomic number of 16? Okay, that would be sulfur. So I'm going to write sulfur here, put 31 there, and put 16 there. Okay? Do all isotopes of an element have the same atomic number? Yes. Give at least one example or counterexample from Model 1 that supports your answer. Okay, so let's just use magnesium. So we have magnesium 25, which has 12, and then we have magnesium 26, which also has 12 for atomic number. Okay, so do they both have the same atomic number? Yes, which means they both are the same element, just different mass numbers. Okay, so let's flip over to the back side. Considering your answers to question 11, I didn't do that, sorry, forgot part B here. Do all isotopes of an element have the same mass number? No. Give at least one example or counterexample from Model 1 that supports your answer. Okay, I'm going to use carbon. Okay, so carbon, you have carbon 12 and then you have carbon 13. Okay? See, they do not have the same mass number. Okay? Considering your answer to question 11, write a definition of an isotope using grammatically correct sentence. Okay? So here, all right, an isotope is a collection of elements that contain the same number of protons but different numbers of neutrons, which changes the mass number. Now, you could have written this any different ways, but that's just the way I chose to write it. Okay, consult the following list of isotope symbols. Which atoms represented by these symbols are isotopes of each other? So, we have PB, it's 20482. Okay, those two are isotopes of each other. And we have 20582. Okay. And then we also have another set, I'll put a colon there. We have BR, which is 82 and 35. And we have 7835. Okay? And then platinum doesn't go with anything, so there's no isotope for that one. Which part of the isotope symbol was the most helpful in answering part A of this question? The atomic number was most helpful. Okay? Well, I hope y'all have a good day. After you fill out your POGIL, go ahead and take your POGIL quiz today because you can use this on the quiz. All right? I hope you guys have a great day.